This is Mathematical Logic for Mathematics Alive, Lesson 1, Propositions, Conjunctions, Disjunctions, and Conditionals. Let us begin with a simple logic problem in the kitchen. How will you boil an egg, or a duck's egg, in exactly 15 minutes if the only timer available is an 11-minute hourglass and a 7-minute hourglass? Solution: first, boil enough water to boil an egg or to cook an egg. If we start the 2 hourglasses together, by the time 7 minutes is over, there is a remaining 4 minutes in the 11-minute hourglass. So, put the egg in boiling water. Then, when the remaining 4 minutes in the big hourglass is consumed, turn it over and wait until the 11 minutes is consumed. Turn off the stove. Your duck egg is cooked for exactly 15 minutes. In this problem, we used common sense and simple mathematical logic. Let us define logic. Logic deals with a scientific method of judging the truth or falsity of statements. Mathematics is a body of statements or mathematical sentences. Symbolic language is important in understanding mathematics as a logical system. Logic is the basis of all mathematical reasoning. Let us now trace the beginnings of mathematical logic. One of the first mathematicians to make a serious study of symbolic logic was Gottfried Wilhelm Leibniz. Leibniz tried to advance the study of logic from a merely philosophical subject to a formal mathematical subject. However, he never completely achieved this goal. Many years later, several mathematicians such as Augustus de Morgan and George Boole contributed to the advancement of symbolic logic as a mathematical discipline. A statement or a proposition. This is a very basic term in logic. A statement or a proposition is a declarative sentence that is either true or false, but not both true and false. Example: Mount Apo is in Batangas. You may not know if the statement is true, but you do know that the sentence is either true or false, and it is not both true or false. But the fact is, Mount Apo is not in Batangas, but it is in Davao. So, this sentence is false. Determine whether each sentence is a proposition or not. Number 1, Leonardo da Vinci painted Mona Lisa. This is a true statement, and it is a proposition. Number 2, 13 is a prime number. Another true statement, another proposition. Number 3, thank you. Thank you is an expression of gratitude, but you cannot say whether it's true or false. So this is not a proposition. And number 4, how are you? How are you is a question, and it is not a proposition. It is not a declarative sentence. Number 5, open the door. It is a command, and you cannot say that the command is true or false. So it is not a proposition. And number 6, online learning is exciting. It depends upon the person who is talking. So you can say whether it's true or false depending upon the person who is talking. So this is a proposition. Simple statements and compound statements. A simple statement is a statement that conveys a single idea. A compound statement is a statement that conveys 2 or more ideas. Connecting simple statements with words and phrases such as and, or, if, then, and if and only if creates a compound statement. George Boole used symbols such as P, Q, R, and S to represent statements, and symbols like and, or, tilde or not, and implication and double implication to represent connectives. Here are the logic connectives and symbols. Statement not P is a negation, and the symbolic form is tilde P, or tilde before the P, or not P. Then we have P and Q. The symbol here is P and then an inverted V and then Q. So P and Q. This is a conjunction. P or Q is a disjunction, and the symbol is P, and then we have a letter V, and that is P or Q. And P, if P then Q, is a conditional, and P if and only if Q is a biconditional. And the symbols are a one-way arrow and a two-way arrow for the biconditional. Negation. The denial of a statement is called its negation. If P is a statement, not P, which is read as not P, is its negation. The negation of a true statement is false, and the negation of a false statement is true. Here is the truth table for negation of a proposition. So, if the statement is P, the negation is not P, and if the statement is stated in the negative or not P, then its negation is positive or P. Examples of negation from a proposition to a negation. Number 1, the dog is barking. The negation is the dog is not barking. Number 2, the bride did not wear a gown. So the negation is we just remove the words did not, the bride wore a gown. And number 3, the man has a backpack. The negation is the man has no backpack. Look at the picture here. The half of the picture is a negation of the other half. So the left side of the picture is gloomy, dry, and dead. And the right half of the picture is bright, alive, and green. So they are exact opposites, and they are negations of one another. Quantified statements. A universal quantifier states that an entire set of things share a common characteristic. Words that describe an entire set, such as all, every, or none, are called universal quantifiers because the set could be considered a universal set. Examples: all birds have wings. Number 2, no man is an island. And number 3, every even number is divisible by 2. An existential quantifier states that a set of things contains at least one element. Words or phrases such as some, one, or at least one are called existential quantifiers because they describe the existence of at least one element in a set. Examples: some birds can talk. Number 2, one even number is prime. Number 3, somebody brought a flashlight. Negations of statements with quantifiers. The words some, all, and no or none are referred to as quantifiers. So if the statement is all P are Q, the negation is some P are not Q, or at least you can give one counterexample to prove that not all P are Q. And then, if the statement is some P are Q, then the negation is no P are Q. Here are some examples. Number 1, all Filipinos are brown. Negation, some Filipinos are not brown. Number 2, some Filipinos have blue eyes. Negation, no Filipino has blue eyes. Number 3, all birds have wings. Negation, some birds do not have wings. And number 4, somebody brought a flashlight. Negation, nobody brought a flashlight. Give the negation of the following propositions. The cat does not need to be fed. The cat needs to be fed. B, the fire engine is working. Negation, the fire engine is not working. C, parallel lines do not intersect. Negation, parallel lines intersect. D, 5 is a prime number. Negation, 5 is not a prime number. E, a right triangle has one right angle. And the negation is a right triangle does not have one right angle. Conjunctions. If P and Q denote two propositions, the compound proposition P and Q is called the conjunction of P and Q and is written symbolically as P and Q. A conjunction is true only if both P and Q are true. Otherwise, it is false. Here is the truth table for the conjunction of P and Q. Suppose P and Q are both true, then P and Q is true. But if either P or Q is false, then the conjunction is false. Or if both P and Q are false, then the conjunction is also false. So there is only one condition for the conjunction to be true, and this is if both P and Q are true. Examples. Determine the truth value of the following conjunctions. July has 31 days and March has 31 days. So, July has 31 days, that's true. March has also 31 days. So, if you get the conjunction of the two, true plus true equals true. Letter B. It is raining and the ground is dry. So if the first statement is true, the second statement cannot be true. So this is a false conjunction. And letter C, January 1 is a holiday and I have no classes on January 1. So both are true and the conjunction is true. Letter D, vertical angles are congruent and parallel lines intersect. So the first is correct, but the second statement is wrong. So the conjunction is wrong or false. Letter E, 5 is even and 4 is prime. So they are both false. So the conjunction is false. State the following compound statements. P, COVID-19 is a pandemic. Q, we need to follow health protocols. R, prevention is better than cure. Number 1, P and Q. COVID-19 is a pandemic and we need to follow health protocols. Number 2, R and Q. Prevention is better than cure and we need to follow health protocols. Number 3, P and R. COVID-19 is a pandemic, and prevention is better than cure. Disjunctions. A compound proposition formed by joining two or more propositions by the word or is a disjunction. A disjunction of two propositions P and Q is P or Q, written symbolically as P or Q. The word or can be used in the inclusive sense, which is equivalent to and or. The word or can be used in the exclusive sense, which is equivalent to either or, but not both. Logicians have agreed to use the inclusive or, meaning one or the other or both. Inclusive or exclusive or, which is which? Number 1, I will buy a car or I will buy a house. So in this sentence, you can buy a car or buy a house or buy both. So this is inclusive or. Number 2, Lisa is cooking an egg or a hot dog. So since Lisa can cook both, then it is inclusive or. And number 3, Johnny is taking up mechanical engineering or agronomy. A student cannot take both, so he has to choose one. So this is exclusive or. Truth table for the disjunction of P and Q. So if we have P and Q are both true, the disjunction is true. But if either P or Q is true, the disjunction is still true because you still have a choice because of the word or, and it is inclusive or. So if P is false and Q is true, the disjunction P or Q is true. The only way that a disjunction can be false is when both choices are false. So F and F gives us a disjunction of false statement P or Q. State each of the following symbolic statements in words. P, I am a teacher. Q, I am a student. R, I am single. Number 1, P or Q. I am a teacher or I am a student. Number 2, P or not Q. I am a teacher or I am not a student. Number 3, Q or R. I am a student or I am single. And number 4, not Q or R. I am not a student or I am single. De Morgan's laws. Not P and Q is equivalent to not P or not Q. To negate an and statement, negate each part and change the and to or. Examples. If P is Anne is present today and Q is Ben is present today, P and Q is Anne is present today and Ben is present today. Not P and Q means Anne is absent today or Ben is absent today. De Morgan's laws. Not P or Q is equivalent to not P and not Q. To negate an or statement, negate each part and change the or to N. Example. P. I received a flower today. Q. I received a cake today. P or Q. I received a flower or a cake today. Not P or Q. I did not receive a flower and a cake today. Or I did not receive a flower and I did not receive a cake today. Conditional proposition or implication. The proposition, if P then Q, denoted in symbols by P implies Q, is called a conditional or an implication. P is the antecedent or the hypothesis, and Q is the consequent or the conclusion. And here is the truth table for the conditional or implication. If P is true and Q is true, the implication P implies Q is true. If P is true and Q is false, the implication is false. If P is false and Q is true, the implication is still true. And if both P and Q are false, the implication is true. It's like negative times negative is positive. Conditional proposition or implication. If I study hard, then I will pass all my subjects. So it seems logical to believe that both will be true. Study hard and pass all your subjects. Number 2, if 2 is an integer, then 2 is a rational number. The first, or P, is true, and 2 is a rational number is true. So this is a true implication. Number 3, if 2 triangles are right triangles, then they are congruent. And we have a case here where the 2 triangles are right triangles, but obviously they are not congruent. So the first statement is true and the second statement is false. So the implication is false. State the following statements in the if-then form or as an implication. Number 1, 2 intersecting lines lie in exactly one plane. So as an implication, you start with if. So if 2 lines are intersecting, then they lie in exactly one plane. Number 2, 2 angles forming a linear pair are supplementary. So start with an if. If 2 angles form a linear pair, then they are supplementary. And number 3, we will postpone the examination in case tomorrow is a holiday. So the word in case replaces the word if. So the if is in the middle, or it introduces tomorrow is a holiday. So we should reverse the statement and we start with if. If tomorrow is a holiday, then we will postpone the examination. In my next video, I will be discussing different forms of conditionals and biconditionals. To complete your lesson in mathematical logic, watch the next 2 videos. Please like, share, and subscribe to this channel by clicking the button below. Thanks for watching and bye-bye!